When supplying power to a portable office trailer with a 125 amps main breaker, 240 volts single-phase service panel from an unused 230 volts, 200 amps, three-phase disconnect, several options can be considered. Firstly, you can install a transformer. This involves installing a transformer near the disconnect to convert the 230 volts three-phase power to 120/240 volts single-phase power. This option provides a neutral connection from the transformer secondary to the trailer's service panel. Secondly, using a three-phase generator is another option. If a three-phase generator is available, it can be used to supply power directly to the trailer's service panel. No transformer or neutral connection would be necessary in this case. Thirdly, a phase converter can be employed. Installing a phase converter converts the three-phase power to single-phase power. This option requires a neutral connection, which can be provided by a small transformer or an isolation transformer. Fourthly, using a single-phase generator is possible. If a single-phase generator with a high enough amperage rating is available, it can be used to supply power to the trailer. No transformer or phase converter would be necessary, but the generator must be rated for the full load of the trailer. Given the substantial load in the trailer, installing a transformer to provide a dedicated neutral connection is generally the best option. This ensures proper grounding and voltage stability for the trailer's equipment. When selecting fuses, the fuses for the two phases should be sized according to the trailer's main breaker rating, which is 125 amps. The neutral fuse should be sized to handle the expected neutral current, which can be estimated by calculating the harmonic content of the load. It is critically important to consult with a qualified electrician to ensure that all electrical connections and equipment are installed and sized appropriately. This is to maintain safety and compliance with electrical codes. It is important to elaborate on transformers for a moment. A transformer is a static device that transfers electrical energy from one circuit to another through electromagnetic induction. It typically consists of two or more coils of wire wound around a ferromagnetic core. The primary coil receives energy from the source, and the secondary coil delivers energy to the load. The voltage and current in the secondary coil are determined by the turns ratio of the transformer. In the context of powering the trailer, the transformer steps down the 230 volts three-phase power to 120/240 volts single-phase power suitable for the trailer's electrical system. The neutral connection is derived from the center tap of the secondary winding. This provides a stable reference point for the voltage and ensures proper operation of the 120-volt circuits within the trailer. Considering generators, a generator is a rotating machine that converts mechanical energy into electrical energy. It typically consists of a rotor, which is a rotating assembly of conductors, and a stator, which is a stationary assembly of conductors. The rotor is driven by a prime mover, such as an engine or turbine, and the rotating magnetic field induces a voltage in the stator windings. Generators are available in various sizes and configurations, including single-phase and three-phase models. In the context of powering the trailer, a three-phase generator can directly supply the required voltage and current without the need for a transformer. However, a single-phase generator must be adequately sized to handle the total load of the trailer, including any surge currents from motors or other inductive loads. Phase converters are devices that convert three-phase power to single-phase power. They typically use capacitors and inductors to create a phase shift in the current, which allows the single-phase load to be powered from the three-phase source. Phase converters are available in various types, including rotary phase converters and static phase converters. Rotary phase converters use a motor generator set to create the single-phase power, while static phase converters use electronic components to create the phase shift. In the context of powering the trailer, a phase converter can be used to convert the available three-phase power to single-phase power. However, it is important to ensure that the phase converter is properly sized for the load and that a neutral connection is provided. The neutral connection can be provided by a small transformer or an isolation transformer. Fuse sizing is a critical aspect of electrical safety. Fuses are overcurrent protection devices that are designed to interrupt the flow of current in a circuit if it exceeds a predetermined value. Fuses are available in various sizes and types, and it is important to select the appropriate fuse for the application. In the context of powering the trailer, the fuses for the two phases should be sized according to the trailer's main breaker rating, which is 125 amps. This ensures that the fuses will protect the trailer's electrical system from overcurrent. The neutral fuse should be sized to handle the expected neutral current, which can be estimated by calculating the harmonic content of the load. Harmonic currents are currents that are generated by nonlinear loads, such as electronic devices and motors. These currents can cause the neutral conductor to overheat if it is not properly sized. Consulting with a qualified electrician is essential for ensuring that all electrical connections and equipment are installed and sized appropriately. Electricians have the knowledge and experience to perform the necessary calculations, select the appropriate equipment, and ensure that the installation complies with all applicable electrical codes. Additionally, it is crucial to comply with relevant electrical codes and standards such as the National Electrical Code, or NEC, which provides guidelines for safe electrical installations. Some specific NEC articles to consider would include Article 220. This covers branch circuit, feeder, and service calculations. This article provides the requirements for calculating the load in the electrical system to ensure it is properly sized. Article 250 is about grounding and bonding. It outlines the requirements for grounding and bonding electrical systems to ensure safety and prevent electric shock. Article 310.15 relates to ampacity of conductors. This section provides tables and guidelines for determining the allowable ampacity of conductors based on their size, insulation type, and installation conditions. Article 450 covers transformers. This article provides the requirements for installing and protecting transformers, including overcurrent protection and grounding. Article 550 addresses mobile homes, manufactured homes, and mobile home parks. This article provides the requirements for electrical installations in these types of structures, which may be relevant to the portable office trailer. NEC Table 310.16 allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees C through 90 degrees C, provides guidance on selecting the appropriate conductor size based on its ampacity rating. For instance, for a 125 amps load, you would need to select the conductor size that is rated for at least 125 amps. The specific size will depend on the conductor's insulation type and the ambient temperature. You may need to upsize the conductors to account for voltage drop, especially if the distance between the disconnect and the trailer is significant. Voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and selecting conductors that minimize it. The grounding electrode system should be properly installed to ensure a low impedance path to ground. This system typically includes grounding rods, ground rings, or connections to metal water pipe. The grounding electrode system should be bonded to the service equipment and the trailer's metal frame. In terms of overcurrent protection for the transformer, the primary and secondary sides of the transformer should be protected by fuses or circuit breakers. The overcurrent protection devices should be sized according to the transformer's nameplate rating and the applicable NEC requirements. If using a generator, ensure that the generator is properly grounded and that it is equipped with overcurrent protection devices. The generator should also be equipped with a transfer switch to prevent backfeeding power into the utility grid. When using a phase converter, ensure that it is properly sized for the load and that it is installed according to the manufacturer's instructions. The phase converter should also be equipped with overcurrent protection devices and a neutral connection. Regarding the neutral connection, it is important to provide a properly sized neutral conductor to carry the unbalanced load current. The neutral conductor should be sized according to the NEC requirements and should be connected to the grounding electrode system. Considering the harmonic currents, nonlinear loads can generate harmonic currents, which can cause the neutral conductor to overheat. If the trailer has a significant amount of nonlinear loads, it may be necessary to install a harmonic filter to reduce the harmonic currents. An isolation transformer can be used to provide a clean and isolated power source for sensitive electronic equipment. An isolation transformer can also help to reduce noise and interference on the power line. When connecting the trailer to the power source, use appropriately sized and rated cables and connectors. Ensure that all connections are tight and secure. Use weatherproof connectors and enclosures if the connections are exposed to the elements. Before energizing the trailer, inspect all electrical connections and equipment to ensure that they are properly installed and safe. Use a multimeter to verify that the voltage and current are within the acceptable range. After energizing the trailer, monitor the electrical system for any signs of problems such as overheating or excessive voltage drop. If any problems are detected, immediately de-energize the trailer and investigate the cause. Regular maintenance of the electrical system is essential to ensure its continued safe and reliable operation. Inspect all electrical connections and equipment regularly and repair any damage or wear. Test the overcurrent protection devices periodically to ensure that they are functioning properly. Keep the electrical panels and equipment clean and free of debris. It is also important to consider energy efficiency. Use energy-efficient lighting and appliances to reduce the load on the electrical system. Install a programmable thermoset to control the heating and cooling system. Insulate the trailer to reduce heat loss and gain. Educate the occupants of the trailer about energy conservation practices. Moreover, ensure compliance with local codes and regulations, which may have specific requirements for electrical installations in portable office trailers. Obtain the necessary permits and inspections before starting any electrical work. Work with a qualified electrician who is familiar with the local codes and regulations. Safety is paramount, so always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow safe work practices and procedures. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. Electrical work can be dangerous if it is not done properly. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work.